This is video help on homework number 8. On problem number 1, you'll notice that I'm actually giving you the answers. So go ahead and write these answers down on your homework handout. The slope is equal to y2 minus y1 over x2 minus x1. These are the coordinates of the so-called slope points. Also, the y-intercept b is equal to y1 minus the slope times x1. So make sure you have those written down on your printed homework handout. Now, when you're entering this into the web form online, again, I give you the equations here, so I'm not asking you to write those equations in. Instead, I'm asking you to calculate some values based on these coordinates, x1, y1, x2, y2. Use those values to calculate the slope and the y-intercept. For problem number 2, on the homework handout, circle the terms that relate to the independent variable, and on the web form, you're simply selecting them from the drop-down list. For problem number 3, you want to refer back to your notes because we did answer this question in class. So you want to type in your answer using complete sentences in this box right here. Let's see, I think I also have this located here. Let's see if I can pull that up. This is a PDF version of that graph. So here it is. It's asking you to compare observed data, empirical data, and theoretical data. For observed data, you're simply connecting the data points. For empirical data, you draw the best fit line through the data points. And for theoretical data, you simply have a trend line in which there are no real data points. You're just trying to predict what the data might look like if you conduct an experiment. For problem number 4, I'm only asking you to do these two problems on your own. The first one and the last two, I'm going to give you the answers here in the video in just a moment. So just to remind you, you're going to be entering these into the web form online, and so you want to type in your answers for the horizontal axis, vertical axis, slope, and y-intercept for those two middle problems, well, somewhat middle problems, the second and third problems. So for this first one, the horizontal axis, that's just going to be x. You're trying to make it so that you get a straight line out of this, so x would be what you would put right here. The vertical axis is going to be y squared, because if you were to plot x versus y, you'd get a parabola. But the instruction says to find a way to make it so that the data that you would plot, or this function that you would plot, would be linear. So to do that, this would be x here, y squared there, k would be the slope, and there's no constant over here, so the y-intercept would simply be 0. All right, so do the same kind of thing for that one. And remember that what you do on this one here is you take the log of both sides and use the properties of the log that we used in the in-class exercise. And you might also remember that the log of 10 is equal to 1. So that's going to do that. For this next one, to make this linear, I mean, if you were to plot this x versus y, it would look pretty weird because you have a power function here and a sine function. So what you would simply do here to make it a linear graph would be to, on the vertical axis, you want to plot the sine of y. So you would just write in sine of y here. And to make it linear, you would put x to the b power right there for the horizontal axis. And if you did that, the slope would be a and the y-intercept would be d. Doing the same thing over here, horizontal axis would be x, vertical axis would be 1 over y, otherwise it wouldn't be a linear function. The slope would be a and the y-intercept would be b. So go ahead and write those down so that when you turn this in for your homework evaluations, you do have a completed homework exercise. On problem number 5, you're asked to plot the data from table 8.5 in the textbook. Here's a table from 8.5 in the textbook, and I'll show you how to download it from the course home page in just a moment. One of the first things you want to do is look at how the data is expressed in the table. You'll notice that this is the voltage in the first column, and the current is dependent upon the voltage. So as you increase the voltage, the current responds to that. That means that this has to be along the x-axis and this has to be along the y-axis, because this is the independent variable here and the dependent variable here. So make sure that you give the graph a title, current versus voltage. Give it a y-axis label, current measured in amperes. And the x-axis label is going to be voltage in volts. So that's the units for voltage is actually volts. I think I've scaled this so that it's pretty easy to get from the table over to the graph. So this will be even easier than what we did in class if you follow this simple guide. Put a 0, 0 as your origin right here. So the 0, 0 origin is here. Notice that it goes up to about 14 volts. So if you just make each one of these divisions correspond to 1 volt, so 0, 1 volt, 2 volt, 3 volt, etc., that'll allow you to plot it along this axis. In the same way, if you use a tenth of an amp or a tenth of an ampere along this axis, it will scale out properly as well. So 0, 0.1, 0.2, 0.3, and of course you don't have to label every mark there. You can just do it every 5, you know, like 0 and 0.5 and 1 amp. After you have the data points spread out there and you have your graph labeled, you want to circle your data points, find 2 points along the best fit line and put squares on them, and use those as your slope points for calculating what your slope is going to be. Now what I want you to do is actually have this line go through the origin. So let's force it to go through the origin for this example. And down here it says the equation of the line. Now what you normally think of and for the equation of the line is y is equal to mx plus b. But rather than doing that, we want to replace the y with the current. Now the letter that's commonly used in electricity and magnetism, in electricity or in electric circuits, is the letter I for current. So we're going to do what the instructions say and use I for current. Also, the x value, is going to be that along the x-axis. So we'll put a V there for that for voltage rather. So you're using V for voltage for the x-axis. There's no y-intercept because I'm instructing you to force that line to go through the origin, so we can delete that. And then what you do here at the end is you put a numerical value in here for the slope. So you're almost done here. You just have to have I equals some numerical value times the voltage V. Now the units on this it's going to be rise over run. So the rise is in amperes and the run is in volts. So it's going to be A over V. This can kind of get confusing because we're using V over here for volts and we're using V right here. We're using V for voltage and we're using V for volts. I guess we can just type out the word to make it completely clear what we're doing here. That might be the best way. So this is going to be a variable V and this is the units, just to keep them separated. They're going to be a number right here that you get from rise over run.